All right, in this example 9, we're looking at a composition of two reflections, one about the angle theta and then one about the angle psi. And we want to show that that's equivalent to the rotation of a angle 2 times the difference of theta and psi. So let's begin. Okay, so notice that we are talking about reflections in the side, and we want to show that it's an equal to a some sort of rotation on the side. So that's where we're going to go. So we're going to take the definitions. This is a pretty straightforward algebraic proof. So recall, if you will, that t of theta, c of psi is equal to something of the form cosine 2 psi, sine 2 psi, sine 2 psi, and negative cosine 2 psi. And p of theta, the reflection of angle theta, is cosine 2 theta, sine 2 theta, sine 2 theta, and minus cosine 2 theta. Okay. And so we're wanting to show that it's something of the form cosine theta minus sine theta. Shouldn't use theta, I guess. Smiley face, sine, smiley face, and cosine, smiley face. So I'm trying to show that the that the resultant transformation of these composition of two reflections is equal to some rotation of this form. Okay. All right. So let's go ahead and compute the composition. And so we have t of psi is being operated on t of theta. Okay. So this is really just matrix multiplication. So cosine of 2 psi, sine 2 psi, sine 2 psi, cosine 2 psi, minus cosine 2 theta, sine 2 theta, negative cosine 2 theta, sine 2 theta. Okay. Multiplying these matrices out, you're going to get cosine 2 sine cosine 2 psi cosine 2 theta plus cosine 2 psi sine 2 theta. And that would be the first element. Okay. So I just kind of give you an idea. So I'm gonna go ahead and write out each of the elements real quick. And I won't say anything here, so you just kind of can see where they're each coming from. Now that we're here, we can use a trig identity and these sums and differences with like products. Whenever you see these, I always think of some sort of trig identity and then I never memorize them, but I just look through or quickly Google what trig identities kind of look like this. These usually are like sum and differences or half angle or double angle formulas. So that's kind of what I look for. And it just so turns out that this first element is the same as cosine of 2 psi minus theta. Bottom one here is sine of 2 psi minus theta. This is sine of 2 theta minus psi. And this is cosine of psi minus theta. Okay. And then notice that every argument is of the form theta or psi minus theta, except for this one here, okay, our element here. But we're also missing a minus sign, okay? So sine being an odd function, I can factor out a negative sign of the sign. And so if we imagine factoring out a negative one here, this would become a positive psi and a negative theta, or I could write this as psi minus theta and put a negative out in front. And so by factoring out a common, because of sine's oddness, I can pull out a negative sign, so this becomes cosine of 2 psi minus theta, sine of 2 psi minus theta, negative sine of psi minus theta, where again, I've factored out like a negative, since psi is positive now, a negative times a negative would put it back to that form, and then a negative times a negative would put it back into that. So that's exactly what we were hoping for. I'm forgetting my 2, and then a cosine of 2 psi minus theta. Okay. And now if we look at what we have here and we compare it to what we were trying to show, okay, we have cosine, negative sine, cosine, or sorry, sine and cosine. So that is exactly of the form of so this is exactly of the form of a of theta of 2 psi minus theta, where this a is the transformation of a rotation about an angle to psi minus theta. Okay, which is exactly what we wanted to show. Okay, all right, I hope that was helpful, and I will see you in the next video.